All right, welcome everyone. This is no-code deep learning. So no-code deep learning for computer vision specifically. My name is Sage Elliott and I work at Plainsight. So we're going to be using the Plainsight platform. I've already just shared the links in the chat so you can sign up as we, or to use the platform as we kind of go through all the steps of how to do the computer vision process in there. Hit record. This is just for me because sometimes I forget, but I already hit it. So setup again, just for anyone who might have joined. Really, the main thing is you want to have a modern web browser and you'll want to sign up for the computer vision platform there. What we'll be covering tonight is kind of high level computer vision use cases and model types. So you'll kind of know what to select depending on what you're trying to build. And then we're going to go through and do a hands-on portion using the Plainsight platform. And we're going to create models and data sets. And then we're going to talk about how to interact with the live API on the SaaS version of the platform. Tiny bit about me. My name is Sage Elliott. I'm a machine learning developer evangelist here at Plainsight.ai. We do really, really cool stuff with machine learning and computer vision, and we're making tools to make it easier for everyone else to do really cool stuff with computer vision. For the past decade, I've worked in software or hardware, mainly with startups and agencies around Seattle and also Central Florida. I really love making things with technology. You can stay connected with me at Sage Codes on Twitter and LinkedIn. You can just search for Sage Elliott, 2 L's and 2 T's, and I should pop up for you. A tiny bit about Plainsight. So I already kind of said, we do a lot of really cool stuff with computer vision, and we're making tools to make it easier for everyone. So we streamline the computer vision process for businesses to understand and act in real-time insights from image data and live video analytics. So we'll talk more about kind of all these steps and how they work together and how having them in one platform can really help you achieve your goals. About you. Normally, I know a lot of people just like watching the talk, but it's always really fun to hear a little bit about you attending. So if you want to post in the chat, again, you can hit that drop down and select for everyone. It'd be really cool to hear about why you're interested in computer vision. Do you have any specific use cases in mind right now? And it's always really fun to see where people are watching from. So if nothing else, you could just throw in, what part of the world or what state you're watching from right now. It's really cool to kind of see the reach of these workshops. And I'm going to share this link again. So if you want to join our Slack channel, I kind of miss really staying connected with people and diving deeper into what you're working on. The Slack channel has kind of been one of the best ways to do that during COVID. And it doesn't matter where you are in the world, we can all talk in there. And there's an intro channel in there as well. So if you just want to post in that introduction channel and kind of talk about what you're working on, we can all help each other out. Cool. I see Dallas, India, Seattle. I'm sure there's quite a few more places that people are watching from, which is always really exciting. And I see more people join in right now too. Setup repeat, again, just for those people join in, and really, you'll just want to have a modern web browser like Chrome, and you'll want to make an account here so you can follow along. And you could also use your own data set. After you see all the steps we're going to go through, it'll be really valuable for you to use your own data set, either kind of during the workshop as we go or after the workshop. And there's no card or anything required. It's really easy to sign up. Just give them your email, make a password, and then you should get an email to verify your sign up, and you click a button on there and you should be good to go. So a little bit about kind of the higher levels of computer vision. If you're new to the field, you've never done it before. What is computer vision? So it's a really big field, but typically I would boil it down to how computers gain understanding from images or videos. And sometimes there's other data types that you might not think of traditionally as an image or a video, but they can be kind of seen as such. And audio is one of those ones. So you've probably seen some sort of audio visualizer before where you see wavelengths and stuff bouncing around, right? You could actually use that and a computer vision model to kind of gain understanding of, what that sound is, or like when someone's speaking different words, like in a personal assistant, it's not uncommon to actually use computer vision models behind the scene to kind of figure out those words. And then you can see there's a demo here on the side where we're showing these cars being detected with computer vision. So they're actually being segmented out kind of pixel by pixel where that car is. And you see the bounding box surrounding them saying, they're within this region. And we think precisely these pixels belong to the car. That's called instant segmentation. We'll talk more about that in a bit. And then you can also see that when they're detected, we're actually tracking them the entire time that they're in the frame. So when one comes in, they get assigned a unique ID, and then we can actually calculate how long that car has been sitting here. So in this case, we're kind of seeing how long is it taking for these cars to get through this drive-through line. And you can also notice that the cars parked, they're not being tracked. We're only looking at things specifically in this drive-through line, and we can actually see when cars exit in real time. So here you can see this, this car is abandoning the line. And then with those insights, you can calculate things like average wait time, the abandonments happening in real time, and also the total abandonments during the day, and how that can affect things like revenue. So you can kind of see, like, this is one use case in a restaurant, but stuff like this can be really used across so many different industries. Like someone was talking about fish before. The same concepts are often used for like counting livestock or tracking people in retail environments. Briefly talk about the full computer vision lifecycle. Today, we're going to use the platform to do data annotation, also called labeling, machine learning, so like selecting model and training it with the data, and then deployment, so running a model on an edge or a cloud device. But really, I just want to briefly mention like all the steps during the lifecycle. You have device management, so collecting data and running your models often happen on other devices that aren't like a cloud server. So you might have an edge computing resource that you need to deploy models down to and collect data from them. And in this case, a sensor would be a camera most of the time for computer vision. You have the data collection. So when you are streaming that data in, you need to manage it, and you usually need to create some form of data segments. And then you label it, then you train a model with it, and then you deploy it. And then often you repeat for continuous machine learning. This is really important for most real world applications. So you might start out with a model trained on detecting people in the summer, and everyone's wearing shorts and tank tops and like baseball hats. And then in the winter, people are wearing completely different clothing, right? And so your model's probably not going to perform as well on all this kind of new clothing during the winter. So you usually want to keep collecting data out in the field, keep training your model with that data, and it's going to become more robust over time and account for things like the seasonality, and you avoid what's called data drift, which is where like the data that was used to train your model no longer really matches the data that you're running detections on. And then version control. So often when you're collecting data sets and you're training models, you actually want to keep track of all the data that was used for specific models and all the different tuning and stuff that you did on those models, and then you can compare how they perform against other models. So we do all that in one platform, and that's where we're going to kind of show off today. You can check out our pricing page for more details if you want to check it out on your own. We also have a version of this platform that can be hosted in Google Cloud Marketplace. So if you're looking for a private cloud solution, that's one of the ways to go. We also do like the data annotation services as well. So if you're not looking to do all the data annotation yourself, we can also do that for you, as well as just completely custom, end-to-end solutions for pretty much any application. So some common model types. Does anyone have any questions so far real quick, or anything they want to add? If not, I'll just keep going. So some common model types. So we'll talk about some computer vision model types that are often used out in the field. We have object detection. So you can see here's an example of labeling for it. So usually we want to label our data set and then train a model. And we'll talk about that and see a hands-on example of it. Object detection allows us to classify what is in an image, but also localize where it is. So here you can see we labeled a data set for airplanes or jets, and then we are running a model to detect jets. And you can see it's actually, it detects one currently, but with object detection, you can also just count how many objects are in the image. So a lot of people want to do this. A good example is, counting how many people are in a room, or someone was counting, or someone wanted to count how many fish there were, right? So you could train an object detection model here to look for all the fish. And then if there's a pretty clear view of the fish from a camera, you can pretty much very easily just count how many are there. And you don't even necessarily need any other crazy models to track them or anything. If you're just taking a picture and you want to see the count in there, which is kind of cool. We have instant segmentation, so kind of similar to object detection here, where we can classify and localize where an object is inside of an image, but we can also segment precisely what pixels belong to the object. So when we saw that example of the cars leaving the drive-through earlier, that was actually an example of instant segmentation. And to label that, you actually have these polygons. So instead of just having a square around it like this, it actually is like traced very precisely around the object. And usually that takes a long time. And I'm not a fan of doing it personally myself, but we have a tool called Smart Polygon Selection that actually just allows you to draw a bounding box around an object and automatically generate those polygons. So it saves a lot of time. Basically, it just takes the amount of time of you labeling for object detection now, which is pretty cool. And you can see here is an example of the segmentation model running on this mouse. And right, it's not just the bounding box. We can actually see these pixels colored in on the mouse itself. And what's also nice about segmentation is with these, pixel predictions, you can actually calculate when they're interacting with other objects. So we're not only detecting the mouse here, we're also detecting this piece of food. And when those pixels are interacting with each other, we're counting the mouse as feeding or not feeding. Was there anything else that's going to add on to that? One example that I really want to see is a virtual reality keyboard that I can actually type in while I'm wearing my headset and not doing just like ones and one letter at a time. So if you could actually build a really good segmentation model of hands, and you could see where each finger is interacting, and when my finger is over a certain button in a certain space, it could actually count it as a key press. I think that'd be pretty cool. Segmentation models also can sometimes have a bit more accurate prediction. So sometimes if you're labeling for object detection and you're just not quite getting the accuracy you need, you could try doing the segmentation labeling and training and see if that increases the accuracy at all. We have feature point clustering or key point detection. So this is labeling kind of specific points on objects. So in this case, we're labeling those points on a human and doing pose estimation. So once we train a model to detect kind of where the positions of these joints are in a video, we can then kind of calculate things like, in this case, yoga poses. But another common one that you'll see people use is hands and doing like sign language detection or controls. And another example of VR, right? Like if you've ever used any of the AR glasses or VR applications with hand tracking, they're often doing something like this and seeing the position of your fingers relative to the other finger. So in the Microsoft HoloLens, when you click on anything, you're doing a motion like this, kind of like putting these fingers together. So they're actually using something like pose estimation, seeing when you do that. It's also very commonly used in face applications. So if you ever see facial recognition or mood tracking or anything like that, you'll usually see dots around certain spots of the face. We have classification. So classification is usually trained on a whole image or a specifically cropped area of the image. So in this case, right, we're just assigning a label. Is there a person or not a person in this photo? And I'm saying there is a person. And then we train the model. And this gives us the detections of if something's in the photo. But you'll notice, right, the difference between this and things like segmentation or object detection. We're not actually drawing or understanding where the thing is inside the image. We're just saying, we think this thing is in the image, but we don't know exactly where. So it's really good for applications if you just actually want to know, did something happen that we were looking for? So in this case, the security camera just wants to know, is there a person there or not there? We don't need to know how many people are there. We don't need to know where they are in the frame. We just want to get some alert if a person shows up. So classification is really good for that type of application. Any questions on those different model types? Do any of them look really cool, or do any of them sound like something you would use for a certain application that you have in mind? I think I saw someone raise their hand. You can just type it in the chat and I'll read it out. Someone said they're entertained the idea of pose estimation for MMA. That's pretty fun. Yeah, I've actually seen a lot of. I actually used to work at a programming boot camp where someone was actually making that model, and I don't know the end result of it because he used to work in like news coverage of MMA, and he wanted to use computer vision to analyze it, which I thought was really cool. And I've seen a lot of use cases around different sports, and a lot popping up right now around, you know, understanding how your pose is like when you're swinging a tennis racket or playing basketball. So pose estimation is definitely being used a lot for that, at least in like research, and people are trying to get it good. I don't know. And I know there's apps you can download. I haven't tried one yet, but there's apps you can download. For example, like I know there's a yoga one actually that you can download, and will try to tell you how good your yoga poses are. Cool. And if you have any questions and I don't get to them here, I'll also be hanging out after the workshop, and we can dive deeper into your questions. All right, so we talked about the kind of label types and the different models. So real quick, I just want to highlight a couple features to create those data sets faster. I mentioned, right, like labeling for instance segmentation can take a really long time, tracing each thing. Even bounding boxes can take quite a bit of time if you have a lot of objects in an image or just a ton of different images, right? Usually working with like thousands of images or more. So we have some features in the platform, and we'll take a look at some of these when we actually go and build our model as well. But I just want to highlight them here. So we have Autolabel. Autolabel is something that's incredibly powerful that a lot of organizations actually spend a lot of time and resources building out internally. So if you imagine Tesla, you know, I can't even like, I forget how much data they're collecting, but it's an insane amount, right? Like if you're driving a car around all day, there's so much data that you want to process and label. So they have an auto labeling system that they spent a lot of time internally building. But we have an auto label functionality built into Plainsight here where you can just turn it on. And if you don't have any models starting out, you can select from some common classes from the Cocoa data set. There's 81 in there, and use it to auto label your data set here. So that's what's happening in this image right here. We're just selecting car and truck, and then we're having the labels automatically applied to this image, which is pretty cool. And then a really cool feature that you can do right now is after you label images and train a model, which is, again, we're going to cover that in a few minutes, you can actually bring that model that you built back into Autolabel here. So if the class doesn't exist in a pre-existing model that we have in the system, you'll be able to train your own custom model. For example, on that the fish example, right? Like maybe there isn't a fish model available, or it just doesn't work well in your use case. You'll be able to label all those fish and then train a model, bring that model back into the data annotation tool here, and automatically apply those labels. And if they're not perfect, like sometimes your model just doesn't generalize as well to the new data set, you can adjust all these very easily just by clicking on them. And again, we'll see that in a minute when we're actually in the platform too. So even if it saves you like 80 or 90% of the time, it's pretty awesome. We have Smart Poly, which does that smart polygon selection. You saw an example of this with the mouse earlier, but it's really, really cool. So instead of drawing, you know, like precisely around these swans, which would take a long time, like it looks really easy, but if you're kind of tracing just with computer vision or with the labeling tool around this manually, like how you used to have to do everything back in the day, it would take a long time. Like it would probably take me a minute or more or something to do each one of these swans, especially counting for the feet like this and stuff. So using Smart Polygon, again, is another way to save a lot of time. And I love using it. And again, if it wasn't perfect on your object, you can just click in and edit it right there too. So again, if it gets you 80 or 90% of the way there, that's a fantastic use. We have track forward. So if there isn't a pre-existing model yet that you could use, you might want to use track forward. What this is built for is a sequence of frames that come from a video. So the object shouldn't be moving around an insane amount, right? Like it should be the same object, and it should be moving like it was filmed in a video. So you can upload a video, label an object, and then it'll try to figure out where it went to on the next frame, which is really cool. So again, it's not using a model that is trained to detect any specific object. It's trained to try to understand where the object that was labeled moved to in the next frame. So another really good time saver. And then like what I do with this often is I can use it on a data set that is from a sequence. So like a video, use this to label it, train a model, and then I'll bring that model into Autolabel, and then hopefully that works well on the rest of my data. And then training with Smart ML. So we have our Smart ML system where once you have the data set labeled, we want to train the model, and we do smart hyperparameter configuration as well as auto stopping. And we'll dive a little bit deeper into this in the platform because I'll actually show you some of those hyperparameters and then how the auto stopping will work. But put pretty simply, we try to take care of everything for you automatically. So if you're not a computer vision or a deep learning practitioner, we're going to try to make those best decisions for you and give you the best model that we can. All right, so we're going to do the platform walkthrough now. If you haven't signed up yet and you want to kind of follow along, or again, you can just sign up now and then follow along with your own data set later, and then let me know how it goes in Slack. That would be really cool. X out of this. And if you do want some data, I would totally recommend that if you have a use case in mind, you should try using this platform with that use case and see how it does. But if you are looking for any data to use, I'll share this. This is the data set I'm going to use today with my walkthrough, which is some airplanes flying around. Let me see if there's any questions real quick while anyone is signing up. So again, fill out the form, you'll get a verification email, and then you should be able to come into a platform that will look like this. But of course, you won't have any projects in here right now. Yep, it's free. And oh, I think I shared the data set, right? It should be in the channel. Again, I'll share everything out in a follow-up email as well. So if you don't save any of these links or anything, don't worry too much about it. I'll get them to you. It should be in the chat now. And you should have access to it, but let me know if I didn't set the permissions right. All right, is everyone who is signed up already ready in this page? Someone asked if the videos will be available. Yeah, I'll share out a recording if that's what you're asking, and then I assume that's what you're asking, but I do have videos in the data set. That's why I got confused. All right, so I am going to get started. So here I'm on my home page. Again, yours will be blank because you won't have any existing projects, but it should look pretty similar. What we want to do is create a new data set because that's where we start building our application. You want to give it a pretty meaningful name. I'm just going to call this Jets Workshop. But you'll probably want to do, fish wherever that data is from. I'm going to hit save and continue to sources. This is where we actually add the data into the project. So I'm going to hit add data. It's this button right here. Let me make this a little bit bigger here. And then we have some options here. So we can upload local files. We can also connect to Amazon S3 buckets and Google Cloud Storage. So most of the time, if you're actually working at a company, you're probably saving data in the cloud somewhere at Amazon S3 or Google Cloud Storage. But it's really fun to experiment with local data sometimes. And that's what I'm going to do here, is just upload a local video file. You can upload images and videos. So I'm going to click choose my file. And I'm going to select this short video here. So I'm going to hit open. And we'll see it's a video. It's 5 megabytes. I'm going to hit upload. It should just take a second. And it uploaded. And if I kind of keep an eye on this processing log, it got uploaded and now it's being processed. So we can do things like create clips with it and segments that we can break out to frames to actually do the labeling. So I'm just going to wait probably a few seconds until this gets completely processed. Does anyone have like a data set that they're going to try to work on after this? Of course, when I do a live demo, some failure happens. Let's try that again. Upload file. If not, I'll upload images. People said it worked for them. Of course. Well, you're not presenting. It only fails for the people that are doing things live and showing it off, right? Try this one more time. If not, I'll just upload some frames. I've done this so many times too. So of course it fails when I'm showing it, which is funny. All right, so you can see upload conversion of Jets is completed. So I'm going to go to this video tab here. So you can kind of navigate around here. You see images, videos, video frames, clips. So if we go to our video tab, we now have our video here. I'm going to pull it up and we can actually play it right in the browser. So if we didn't know what all those clips were, like we pulled over a ton of them from an S3 bucket and we actually want to go through, kind of scrub them and say like, yes, we want to label this or not. We can pull it up and play them here. And then what's really cool, this is only a 3-second clip here, but we can create clips from those videos. So often you might be collecting video in giant chunks. You might have like an hour or 30 minutes or something sent over each time. Chances are you probably don't want all of that video, depending on what you're doing and the way it's collected in your data set. So for example, if we were looking at some factory floor and we were recording 24/7, but only 4 hours were actually useful for a data set, we could go in and play it, find where those useful hours are, and create a clip of just those hours. So we can hit create clips from video here. This brings up this interface. And then I hit add clip. And you can actually get really precise and type anything here down to the millisecond, or you can drag and drop here. So I could play my video, and if I was like, I only want this full first second here, this will give me that clip. So I could do that, and then I could hit create clip. But for this video, it's just 3 seconds long, so I'm going to use the entire video to label. I'm going to go back and I'm going to hit create frames from video. So this is going to take this whole 3-second video and then create images from it that I can label. And you get to choose how many frames per second you want to break this down to. So I'm going to select this per second. You can do second, minute, or hour. And I'm going to say I want 5 frames per second. So this should give me about 15 or so frames. It might be slightly over 3 seconds, so we might get a couple more frames. And I'm going to hit create frames. And then you'll see it says, hey, stuff is happening. It might take a few minutes. So you can hit got it and exit out of this. And you'll see back in our processing log that it gave an update here. Frame generation started for our video. And then again, this should just take a few seconds or a minute, and we should get all those frames. Oh, yep, we already got them. So frame generation completed. And if we go over to our video frames now, we can hit this little free refresh button, and we can see all of our data is in here ready to be labeled. So let's go to the next tab up here, which is label definitions. And this is where you want to know kind of what you're going to be building at this point. So if you're going to be counting fish and you think the object detection model is going to work well for that, bounding boxes are great for training the object detection models. Otherwise, if you need the instant segmentation, you might want polygons, feature points for pose estimation, which by the way, the feature points aren't supported for the auto training in our platform yet. And then classification for, like when we saw detecting if someone was in the frame or not. So in this case, we're going to leave it bounding box, but for your project, you can go ahead and totally pick different ones, especially after the workshop, right? If you're going to spend more time labeling. And color, this is really for you as a labeler. I usually like having a color that really pops out. So if I know that, my airplanes are on like a dark background, I don't want a label that kind of looks like the sky, or maybe I don't even want a blue one because I know some of them might be on the blue sky. So I want a label color that's really going to pop out and allow me to see it as I'm labeling. So I'm going to leave it this nice pink color and then give it a name. I'm going to call it jet. You can name it airplane, something like that if you're following along. And then I do just want to mention, you can configure that auto label thing we were talking about right here, but I'm going to configure it on the next screen. But I do like to call it out here if you do want to do it in this area. And I'm going to hit save. And then also down at the bottom here, we have this nice instructions area where if you're handing this project off to people, or even if you're doing the project and you're working on a pretty complex data set, or you are not a domain expert yourself about that data set, for example, if someone told me to label samples of tumors or something, I'm not a doctor. I probably don't know what they look like. So I'd want to see samples of them properly labeled, maybe unproperly labeled, and I could embed those here that I could reference as I am labeling them. I'm not going to put anything here today, but keep that in mind. It's really useful, especially if you're handing off to a team or you have multiple people working on the project. So I'm going to hit save and start learning or start labeling. Hopefully we're learning already. So we have our bounding box label over here. If you had multiple labels, they would all show up in this list, and you would just want to click on the one that you want to label for the frame. So you can zoom in with your scroll wheel. You can also move the images around. If you move the image too far around and you kind of forgot where you put it, you can hit resize to fit, and this will bring it back to this default view here. So I want to label my airplane. I could maybe zoom in and I could manually draw this bounding box around it. But we already saw some samples of auto label and everything, right? So why would we want to manually do it if we can have AI do it for us? So I'm going to hit this little drop down of this arrow. I'm going to hit auto label. And then I'm going to select from, which model am I going to choose the class from. So I'm going to hit this default Cocoa bounding box. Everyone should have this. This is built in to the system. You don't need to import it or anything like that. And then here we can kind of browse through all these different classes in here. We can actually see airplanes right at the top, right? Because it starts with an A. But I just want to mention, like, if you wanted to detect benches, for example, that's in here. Broccoli is in here. So if you're doing broccoli detection, this could help auto label your data. But we're going to hit airplane. And then I'm just going to hit OK here. And you can see it just automatically applied that label. And it looks pretty good to me. But I just want to mention that if it did seem slightly off, right? Like if our model just didn't generalize well to the new data and maybe it was almost there like this, I could go and I could drag this out and fix it. And, not a huge deal maybe for just one bounding box. But if I had 20 instances of the planes in here, I would want to label every single instance, right, for object detection. And it could just apply the label to all those. And then I could manually go in and fix any if I needed to. But in this case, it looks great. So I'm just going to hit submit. We're saying this label looks good. We're good. We're done with this image. Then you see the labels automatically applied to the next image. So at this point, PlaneSight is really already labeling our data for us. And we're just making sure that it looks correct. So we're basically just doing quality assurance. Yep, looks good. And submitting all these images right now. These all look pretty good to me. So I'm just hitting submit for each one. What does everyone think of this? Have you seen Autolabel before? Have you used Autolabel label before? I see some people says it looks great. I see some other questions in there. I'm going to keep going just so I can make sure we get through all the content, but I'll be hanging out and I can answer any other questions that I don't get to. Are you going to use this on your project you were talking about, or at least give it a try? All right, so I'm gonna hit submit, and that's all for this data set. Again, we're just building a really small kind of toy sample here for detecting airplanes, right? You usually will want at least hundreds of images to kind of start out your project. And then often you'll move into like the thousands of images, if not even more than that in a real application. So here, just keep in mind, like I didn't want to spend too much time during the workshop because watching me label for an hour probably wouldn't be too fun. Though if we spend an hour labeling with Autolabel, that would be an insane amount of images done, right? So here also we have the ability of reviewing all these images. If I scroll down, I can kind of see like a very quick preview here. But if I handed this project off to someone else on my team to do the labeling, and I want to make sure they did it correctly before we go train our model, I can actually go click into it and I can hit approve or reject on any of these images. So like this looks good to me, I can hit approve. Now I don't want to go through and do all of these because I know they are already pretty good. I already looked at each one as we labeled it. So what I can do is I can just hit approve all up here. So I hit confirm. Now they're all approved. And now our data set is ready to be used for training a model. Again, you would probably want way more images for your actual application. So we'll go to versions. This is where we get version control of our data set. So every time we're going to train a model, we have to lock a data set. We're saying, all right, we're basically bookmarking the place and time that, how this data set looked at this place and time. So we're going to lock this version. And if we want to make a new version, we can keep adding data to this data set. If we collected more images of jets flying around, we'd probably want to add it in, just like I was talking about, that kind of circle where you want to do that continuous machine learning. You can keep adding to the data set. It's just every time you train a model, you need to kind of lock that version in so you know what data was in that model. or was used to train that model. So from here, we have two options, train and export. If you click export, you'll see we support kind of the most common types of computer vision labels, including CreateML, which is Apple's versions, Cocoa, YOLO, Pascal, VLC. And we're not going to use that today, though, because we're going to keep training in the platform. So we're just going to hit this train button. And this brings us to this model page. You got to give it a name. We'll say, what did I call this? I think I said Jets Workshop or something like that. That's what I'm going to type out here. Jets Workshop. Yeah, Jets Workshop. And you can see the data set being used. The data set version was number 1. Here you have the option. So we only used bounding boxes, but if we did label with polygons and it wasn't automatically selected here, you could go and manually select it. And also, if we had more than one label in our data set, we could choose, well, you know, we only want to train on this one, or we only want to train on or this set amount of labels. So we only have one here. We have jets, but if we had jets and helicopters and geese, you know, we could just select jets if we only wanted to train our model on jets and none of the other ones. We have our training time. So this is the maximum amount of training time you want to budget to train your model. I'm just going to put 1 hour for now. It should not take nearly that long. We don't have that many images, right? It should be very quick. And the maximum amount you can set is 24 hours. But this is where that auto stopping comes in from SmartML. So I'm going to set a budget of 1 hour. But unlike a lot of times, if you just go, you know, do some other platform or program your own solution, you're like, all right, go train for 1 hour. We're actually going to evaluate the model as it's being trained and then stop it when it gets as good as it can get with the data that we're providing it. So in this case, we have a very small amount of images. It's going to be like a minute or 2, and then we're going to stop training. But this is really great because it saves a lot of your GPU time. Typically, most of the time, you're going to probably reach an optimal solution before that training time reaches the end. And I mentioned the hyperparameter tuning. So the SmartML kind of takes care of automatically configuring these for the best fit for your model and data. But if you do know what you're doing with deep learning or computer vision, or you want to mess around with these things, you have the option to do so. So you can toggle this on, SmartML hyperparameters. And we have our training, validation, and test split. That means we're using 80% of our data for the model training. And then it's common to have a validation set. This actually gets used during training, and that's how kind of SmartML knows how to stop. We're going to train on 80% of the data. Then we're going to look at 10% of that data as we're training. And when we aren't improving on doing predictions to that data that the model's actually never seen before, then we're essentially going to stop training. And then we have another holdout test data set that we can do other tests on as well and make sure that the predictions are what we want. We have several backbones you can choose from for our model, and you can adjust the learning rate and batch size. I mean, again, those are more advanced things, so don't worry if you don't know anything about them. You don't really have to touch them. And then we have some other settings as well. Augmentation is a really cool thing. So when we look at our images for our computer vision model, what we usually want to do is slightly change them each time we look at them, or each time the model learns from them. So we're going to look at the image of the jet, or the model's going to look at it, right? Try to learn patterns. And then when we feed that model back in, we might do some very slight change to it, like skew it or zoom in or add a color to or flip it a different direction. And that allows us to generalize on data data variations that weren't actually in our data set. For example, right? If all the jets are only pointed in this direction, but then the new data that we want to run predictions on has a jet pointed the other direction, chances are with our flipping and stuff in our augmentation, it's going to generalize better on that data set. So I'm going to go ahead and I'll just uncheck this, and we'll hit save and start training. So we set everything up, just hit train. And then this can actually take a few minutes to configure the resources to do the training. So instead of waiting for those few minutes, what I'm going to do is jump over to a model that I already trained, and we can go back and check on this later though if we want. So once you have a model that is trained, you can see here, I set the budget for this one for 1 hour, and it only took 7 minutes to train. And I actually used more data in this one. So I think I labeled something like 200 images. So it took a little bit longer probably than our other one's going to take, but you'll have this dashboard as your model's training. and then also after it's trained. So you'll see some metrics like it succeeded, the amount of time, the accuracy on the validation test data set, the loss, and a kind of a dashboard of some of those metrics. And then what's cool is you can come down here. We can look at our test data set. Remember, these are images that the model has never actually seen before. So we can see how it did running predictions on them. This is the ground truth data annotation. It might be kind of small on my shared screen, but you can see that it's labeled jet and there's a bounding box around it. So that's what I provided the model or provided the model to test the difference between. This is the ground truth. And then we want to see how well the model actually is drawing this bounding box and how close they look. So if I hit the model detection here, I don't know if you can even see it. Like if I wasn't paying attention, I wouldn't see it, but it looks almost exactly the same. It moves just very slightly. And that's awesome because that means our model did a really good job of understanding what we were looking for and applying the bounding box almost exactly as I would expect it, right? That's pretty cool. So you could click in and kind of look at those on various images if you want. You can also go on the validation data set. Also click in and you can see again, like barely moves here. You can also do this on the training data set as well. So this is the data it's actually learned from. So almost all the time, this should be almost perfect here. Again, it looks great. So now let's give it something a little bit harder where we want to give it a test image that was taken on a different day and the jet is actually in a completely different position as well. So if we looked at this data set, there's one with some blue skies, there's one with a gray sky, and then all the jets are always pointed in one direction. So I'm going to go in and I'm going to take this test image here. So I should call out how I did that real quick in case you weren't paying attention. I'm just going to hit test model, this test model button. You can only hit test model once your image or your prediction API is active. So this button will say start image API if it's not active. That's going to actually spin up an API where you can then pass images to your model to get predictions on them. And we'll talk about how to use this in code in a second, but real quick, you can do this test model feature here. I'm going to go grab this frame. And you can see it returned that really fast. But the jet is in a completely different position and the sky is a different color here. It's kind of a different angle and we're still getting a nice bounding box drawn around it, which is pretty awesome. Any questions so far? I see there's some in the chat. I'm going to try to catch up. How does this look to everyone? Does it seem pretty cool? Are you excited to try it on some data? Brian said it looks great, super user-friendly. It's pretty awesome. I love it. And I even like programming and stuff, but like, why would I want to spend time programming a model if I can just do it in a nice GUI? Ooh, someone mentioned it'd be great to get a certificate from this workshop. Glad you mentioned that. That's actually totally something we are working on. So I'll probably ping you about it later. I just see stuff, people saying it looks awesome, especially if they need to deploy a model quickly with limited time. It's so cool for doing those like quick experiments too, because I anytime I have to deploy a model, that's like usually my least favorite part outside of like plain sight. If I am programming anything and I make a cool model locally, deploying it to me is like always a pain. So having it in one platform like this, it just makes it so easy. So once it can the model available for export after training to Google Cloud Platform. Right now in the SaaS interface right now, you can't export a model. But if you do want an export a model, you can definitely talk to us about the enterprise side of things. All right, so we saw kind of end-to-end all in the interface here. I know we only have a few minutes left on the hour that I booked for this. So let's go ahead and see how we would interact with this API on a on like a code environment with Python. So working with the API right now, live in the SaaS version, you can train a model just like we did. I'm using the production SaaS version there. So everything I just did, you can do in your trial. So you can train a model, deploy it, and then you can interact with a live API with something like Python. With the enterprise version, we have support for a lot of other forms of deployment, including like the edge nodes or probably any other solution you'll want. And something really cool coming soon is kind of the GUI deployment pipeline. So right now, when you have it deployed, you want to start using it, you're probably going to use it in Python from the SaaS version. But we have features coming really soon where you're going to have a lot of other deployment options all in the GUI, and even kind of creating whole computer vision applications completely in plain sight. So I'm really excited to share that when we release those features. But in the meantime, if you do want to hear more about that, or you think that's the right solution for you right now, definitely contact us from one of those links earlier. So I'm going to open up this Colab notebook though. There's going to be a little code here, but don't worry if you've never programmed before. I'm going to walk through what's happening, and it's not that much, but don't worry, you don't have to do it either if you don't want to. So I'm going to share this link in the chat, and if you want, this will open up a Google Colab notebook, which looks like this. And if you've ever used Jupyter notebooks before for data science or machine learning, it's Google's way of hosting that notebook, except for they also give you a whole little Ubuntu instance behind the scenes and pre-installed libraries. So you actually don't have to like pip install most libraries here. You can just kind of import them into your project. So I'm going to open mine up. So you should get this version. And what you want to do if you want to run the code and make edits to it. So like maybe bookmark this. Again, I'll email it out though, so don't worry about it. But if you want to use this in your personal project or work project after this workshop and do just everything we did in the platform, and then use this notebook as a starter, you'll want to save your own copy in Drive so you can make edits to the code, because you want to put in your own image paths as well as your own API keys. So if you're here, just go ahead and hit Save Copy to Drive. I'm going to use this copy I already have here. So I'm going to run this first code cell. All this is doing is importing some libraries that we want to use in our Python project. So I won't go into super detailed explanation of each one right now, but you can kind of see as we use them. And then I commented this out. So if you see these green lines in Python with this little hashtag in the front, that's a comment. It means if we run it, it's actually not going to do anything. And you can run these code cells by hitting the play button or Shift Enter when you're highlighted on it. But I left this here. So if you are using this in your project kind of after this workshop or something, it's a really good idea to actually mount this notebook probably to your Google Drive, and that'll allow you to connect to folders and images and stuff that you have saved in Google Drive. Otherwise, we can upload an image right here in Colab and stuff, but it's not persistent over time. So every time you need to reconnect or you disconnect from the environment, you'd have to re-upload them every time. So I definitely recommend, if you're going to do some more long form experiments, to kind of run this code cell and actually connect it to your Google Drive so you can interact with images and videos that you have saved there. So now the next code cell is setting up our environment variables. Yours won't be pre-filled out. So I'm going to talk about the three things I did. That's adding a path to the test image and adding a path to the model URL. That's our deployed model on the API, and then plain sight API key. So I'll talk about how to get all of these. So for me, what I did here is I took this test image, I'll take this other one, and I just drag it in to this column over here. And if this isn't showing up for you, this column on the side, you can hit this little folder icon, and that'll bring up kind of this exploring area of all the files in the Colab instance. And then to get that path for it, I actually just copy or right click, hit copy path. And then you would just replace that filler text with in your notebook with this path, which is going to be /content, whatever that image was, if you uploaded it this way. If you connect to your Google Drive, you'll have folders in here from your drive, and you can kind of click around in them like this, expand them, dig in, and then find the file you want and hit copy path and paste it in. And then here we have our model URL, and then down here is the API key. So how I get that is I go back to our deployed model, and this is the model URL here. So right under this active status image API URL, just hit this button, it'll copy it to your clipboard. And then you go in and you'll just paste that right here. And then our API key. So you've got to go back to the platform. And then the API key is going to be under your settings. So you need to generate a new one if you don't have any already made. So I went to settings, it has my account. I'm going to go to API keys. I already have one, so I'm just going to keep using this one. But if you don't have one here, you can just go and generate a new one, give it a name, and it will come up like this. And then hit copy to your clipboard. Go back to our notebook and then just paste that really long key into the placeholder value here, plain sight API key. So I'm going to go ahead and run this. Setting up, we said, all right, go ping at this API, and here's our key. So we know you're allowed to go ping this API and get predictions returned. And then here, we're just setting up a couple of things. We're importing our image from that path, and we're changing it to a base 64 image that we can work with here. Then we're getting our response. So we're doing a post request to that API. We're passing the image in, and we're going to hopefully get predictions returned. So if I run this, we have our payload variable that we set to get that response, that JSON response. And then we have the pretty print library that actually prints it out in a way that we can read it, which is nicer. And here's what the response looks like from our API. So for object detection, right, we got a status of 200, which means cool, it worked. And then we have an object, and the key for that is jet. So we detected a jet, which is what we defined when we create our label schema. And then you'll see 4 points returned. This is what's going to draw out our rectangle, right? If you look at a bounding box around the objects, there's 4 points: a starting point, an X dimension starting point, and an X dimension ending point, and then same with the Y up and down. And that's going to give us that bounding box. You'll notice here, though, that they are kind of normalized from a value of 0 to 1. This allows us to kind of get these bounding box coordinates and then scale them to any image. So you'll see just in a second, we're going to essentially multiply them by the width and height of our image so we can draw that bounding box out accurately. Then we get a score. So that new jet that we passed in, it was 80 or 98% confident that that was a jet. And then the type is rectangle. So if you had polygons, it would look slightly different. We'd have some points, and then we'd have to kind of draw those polygon points out instead. And then this next one, this next code cell, we're essentially just going to kind of work with this JSON object and make it into an object that we can work with a little bit easier with OpenCV. So I have a color value here that we're going to use. That's going to be the color that we're going to paint the label. We have the color of, you can use a dictionary to kind of set different colors. If we had multiple labels, like if we had the jet and the helicopter, we probably want different colors for each one. And we could use this color dictionary to kind of set different colors for them. And I'm going to read in that image with OpenCV, which is a really common Python library to do image processing. And we're going to get some metadata from it. We're going to get the height and width. And that's how we're going to actually transform those normalized coordinates, this 0 to 1 value, into pixel coordinates that will work with our image. We're going to create a new list called annotations, and then we're just going to loop through each object in our JSON object. And for the detection, so each time there was a detection, we want to essentially just append those X and Y coordinates in. And then we're going to scale those X and Y coordinates by the width and height of the image. And again, don't worry if you've never programmed before and it feels a little over your head, you can run this code cell and it should just work. So if you feel a little confused, don't worry about it. And then we're going to append all kind of like these transforms we did just to a new object. So we just kind of took this object we got and we did a couple transforms to it. And then we're going to use that new object to draw those coordinates out. One other thing that's in here too is if the model, if you wanted to kind of set a threshold to only draw out predictions that were above certain confidence, you could do that here. So if I definitely didn't want any predictions that were under 55% confidence, I could leave this value here. If I only want the values that are like 85%, I could change that here as well. And so I run this code cell, and you actually see this prints out. I should remove this code, I just commented. This prints out our new annotation object, or our new prediction object. So we see there's a bounding box. These are now pixel coordinates that actually match up to our image, not the normalized ones. We can see the class that was predicted was jet, and here's the color for it, and then the score. And if we had more than one airplane or jet in this image, we would have a whole bunch of samples of these. So we only have one predicted, but it'd be a list of all these different values for each detection. And then just run this code cell below, and we are basically just drawing a few rectangles with OpenCV. So here we now have our new bounding box coordinates, and we're just pasting those into the OpenCV rectangle drawing function. And then we're printing out the object class, which in this case was jet. And we can see that it scaled correctly to our image, which is pretty cool. Not sure if I can zoom in. Oh, there we go. And it's drawing out the accuracy in there too, so 99%. So you went through all the steps of labeling your data, training your model in plain sight, and then working with the API. And even if you've never coded before and you've run all this, this is pretty cool. And you've gone a long way of like building a actual computer vision application. Just a quick summary. So I'm going to share all these links again in the chat. So you now kind of know how to use the plain sight platform. I think we saw the steps like I just said. The next steps hopefully would be, join our Slack channel. If you have any questions about anything, it's a great place to ask them. And if you start working on your project, you run into any issues or you just have questions about it, ask those questions there. And you can DM me, but I always like it when people ask them in a public channel because other people can learn from them or also answer them, right? And then definitely try it on your own data set. So even if you did go through kind of the jets today, it's way more fun and useful if you use it on your own data set. And then if you have any questions or maybe this deployment option or something isn't working for you right now, and you actually want something like the edge node deployments, or you want us to build the computer vision application for you, you can contact us at one of those links I shared in the chat. So I'm going to stop recording. That's all the content I had kind of designed out for you today, but I will be hanging around answering any questions that you have. So give me a second to stop the recording and I'll catch up on chat.